Welcome to the lecture on capitalized equivalent and capital recovery with return. So, these are the two bases of comparison again, and we will discuss one by one. So, what is capitalized equivalent amount? This is a special case of present worth basis of comparison, and it is useful when the life of the proposed project is perpetual. So, many a times we deal with situations when the life is perpetual and you are investing something at present, and the life is considered to be very long. So, that is what it is perpetual. It represents the basis of comparison in which single amount at present time will be found at a given rate of interest. So, rate of interest anyway is defined, and your job will be to find the single amount which is required to be invested at present, and this amount should be equivalent to net difference of receipt and disbursement when cash flow pattern is repeated in perpetuity. So, basically the cash flow pattern is required to be repeated in perpetuity in the long run, and that is how you get it. So, also the cash flow first can be converted into equivalent cash flow of equal amounts that extends to infinity. So, you can have a cash flow which basically is going to infinity, and you are getting basically the equal amount every year for the infinite time, and it is the capitalized equivalent is same as the present worth equivalent when n is approaching towards infinity. So, that is how the n is going towards infinity. So, basically you are having a capitalized equivalent is nothing but the present worth equivalent when cash flow extends forever, and it is coming as a by I. So, how that is coming, that we will see. So, basically the capitalized equivalent is represented by CEI, and it is as we know that it is the PWI, and where n is basically approaching towards infinity. So, we know that we have to have the relationship between P and A. So, basically CEI we can write capitalized equivalent, we can write as A into P by A I infinity. So, basically it is the present amount. So, A into P by A I infinity, that will give you A. So, basically for finding P, if you know A, then A into P by A I n factor will give you P. So, that is how you calculate in the normal cases when you know n, but here n is basically infinity. Now, P by A I n factor is basically defined as it is 1 plus I raised to the power n. So, it will be n is infinity minus 1 divided by I into 1 plus I raised to the power infinity. That is how it is defined, because we know that P by A I n is I into 1 plus I n divided by 1 plus I, no, it is basically the reciprocal of it. So, it will be 1 plus I n minus 1 divided by I into 1 plus I n. So, that is what the P by A I n factor is. Now, this n is, since it is approaching towards infinity, so in place of n we are putting the infinity value. Now, if you take if you do that separately, you put the terms, it will be 1 by I minus 1 by I into 1 plus I raised to the power infinity. And when I is n is towards infinity, so it will be approaching towards infinity, and this term will be vanishing towards 0. So, this term is basically 1 by I. So, now what we see is that CEI, it will be A by I. So, if you know the annual amount which is required to be to be received by you, then in that case you can have the capitalized equivalent amount, and that will be found by dividing the A by the interest rate at which the cash flow pattern will be subjected to. And once you know that, then A by I gives you that. So, if you see basically if you look at it in a very rough way, basically A will be CE multiplied by I. So, CE basically is the amount which you are investing today, and CEI basically is the amount which will be amount of interest which will be generated in any year. So, basically you have kept one amount in the investment as an investment, and from that investment that interest amount generated you will be getting every year. So, since you are whatever interest is generated, you are taking it out. So, the amount of investment which is there, amount of investment amount that is anyway remaining the same, and that is why the next year again you are going to get the same amount as the interest. So, that will go till the infinity time. So, that is on that concept basically this capitalized equivalent amount is basically defined. Now, its use will be mostly for for setting up of certain, suppose municipal gardens, or for any park, or so somebody wants to set a park, and the maintenance of the park requires and other expenditures required every year, you require 1 lakh rupees for that. In that case, what should be the amount which should be put in the bank at certain rate of interest, so that 1 lakh rupees you are getting every year end. So, basically that kind of problems, in those kind of problems we require to use such concept. So, we can have one example. Suppose that you have so a philanthropic companies, the foundation is there, and they want to build a park, they want to gift a park to someone, and then it should be maintained forever. So, suppose a park is to be built and maintained forever. So, now for that you require to set up a fund. Now, annual interest is which will be earned, it will be and that too for perpetuity case is 8%, and annual maintenance cost is something like 16,000 rupees. So, annual maintenance cost suppose is 16,000 rupees per year, okay, for first 15 years, and further it will be increasing. So, and increasing to 25,000 rupees for after 15 years. Now, this may be very practical to see that, because as the time progresses you will certainly see the increase in its maintenance cost. Now, if you want to have a fund, somebody who wants to gift this park. So, basically what should be the present amount of investment, so that you are going to get the amount which is there required annually to maintain this park, for building and as well as for maintaining that park forever. So, for that what we do is, this is a case of the capitalized equivalent amount, and for that you will get the CE8. So, what you see is that you are annual maintenance cost is 16,000 rupees for the for the first 15 years and then 25,000 rupees for after 15 years. So, the gas flow will be going like this. So, you are investing some P and then you are getting 16,000 for first 15 years. So, it will go up to 15 and from 16 you are going to have to infinity. So, you are going to have the requirement of 25,000 rupees. Now, this basically can be understood as an infinite A amount of 16,000 plus also extra 9,000 rupees from the 16th year onwards. So, that is how you can tackle this problem. So, basically what you see is that for 16,000, for this 16,000 getting for infinite time for perpetuity case, you know that that amount will be A by I. So, 16,000 by I and I rate of interest is 8%. So, it will be 0.08. Then this 9,000 also you are getting for infinity, but you only require from 16th year onwards. So, you have to have the that amount. So, again, so this 9,000 will be also required that will be for 9,000 when you require from the initial period, but then you only require the amount from 16th year onwards. So, basically you are going to have it mapped with the factor by multiplying the factor with P by F 815. So, you require here basically you do not require for these situations. So, for that this amount you want the equivalent amount from this point. So, that is why you have multiplied that with P by F 815 and that will be 0.3153. So, basically if you, so that can be seen P by F 815 you can see from the table P by F and 8 and 15. So, it will be this 3152. So, 53 or 2152. So, that way you can put it, and what you are getting is that you get 235471. So, this amount will be required for that setting of the park. So, we can understand this in a different way also, that if out of this amount basically the 2 lakh basically will be used for giving you 16,000 every time, then rest amount is 35,471. This 35,471 is basically deposited for 15 years. So, if this 35,471 its future amount will be for that you will be multiplying with F by P 815. So, that will give you this factor will be 3.172. So, that will give you something like 112515, and if you take 8% of this. So, 8% of this amount 8112,515. So, that one will be coming close to 9,000 rupees. So, this 9,000 extra 16,000 plus 9,000 25,000 you are getting from this time for perpetuity. So, for all the period you are getting. So, that is how you may have different, you may look you may encounter with different cases and you have to solve such problems. Now, we will come to the another point, another terminology that is capital recovery with return. Now, what is capital recovery with return? This is for an investment. It is the equal annual cash flow over its life that is equivalent to capital costs of the investment. So, basically capital cost means whenever we have an investment and we know the time period for which the investment is going to take is being done. In that case, when the investment is over and you have put the capital, then you have also some salvage value of all this capital. So, you have that includes the initial outlay whatever you have invested, and in the end basically you are going to get some amount after selling it. So, that is your salvage value of the plant. Suppose you are establishing a plant, then once you are selling the land cost or the equipment cost or so. So, that will be the salvage value. So, basically when we are taking that into account, in that case whatever because you have also the recovery of the capital. So, that is why that amount that that annual equivalent amount basically will be known as the capital recovery with return. So, here you have two transactions involved, first cost and the salvage value of the asset. Now, what we see that here we see that you have the P as the first cost of the asset, and F is the estimated salvage value of the asset, and N is basically the estimated life of the asset. And in that case the capital recovery. So, the capital recovery with return, if you try to define, now what we see that you get some kind of cash flow pattern. So, basically your cash flow pattern goes like this, that you have invested some amount here, you have invested here, and at the end basically you are getting some salvage value. So, that is what the case is. So, for this basically you require to know one equivalent cash flow diagram, or this A you are trying to have. So, this will be P and this will be F, and P is your the investment capital amount which you have invested at present, and F is known as the future salvage value. That is what it is telling. This F is basically the estimated salvage value of the asset, and N is the estimated life of the asset. So, this time will be you have n years. Now, in this case you will have some P. This P has some A component. Ultimately you are going to have a that amount of equal annual value which should represent this cash flow diagram. So, that is what is the capital recovery with return. So, for that what we do is that you are getting the P multiplied by the factor A by P I n. So, this factor being multiplied with P, it will give the equivalent annual value for that P, and then similarly the F when multiplied with A by F I n, that will give you the equivalent annual value for the salvage value what you are getting. Now, one is positive and another is negative. So, this P is negative and F is positive. So, if you take from the perspective of the investor, so he has put in P and we are taking that the negative direction, the downward direction as the positive one. So, it will be P and then this upward direction will be F minus. So, that way you can get the capital recovery with return value as P of A by P I n minus F into A by F I n. Now, you can we have discussed that there is some correlation between A by F I n and A by P I n. So, we know that A by F I n will be I by 1 plus I n raised to the power n minus 1. Similarly, A by P I n will be I into 1 plus I raised to power n upon 1 plus I raised to power n minus 1. So, that way you see that once I will be subtracted from 1, you will get this. So, if A by F I n will be subtracted, we will be represented by A by P I n minus I, then it will be again P into A by P I n, F into A by P I n, and then again F I. So, this will be the final expression P minus F A by P I n plus F into I. So, that basically is the equal annual cash flow over its life that is equivalent to the capital cost of the investment, which includes the first cost of the investment and also the salvage value of the investment. Now, this we can understand with a problem, and this problem will be something like suppose you have a situation where your asset is has first cost of rupees 5,000 and estimated life is 5 years, and and estimated salvage value. So, estimated salvage value is suppose rupees 1,000 at the end of its life. So, salvage value is at end of its life. So, you have to know the capital recovery with return. So, at 10% interest, what will be the capital recovery with return? So, basically you are going to have CRR 10. So, CRR 10 is to be found out. Now, as we know that you have P as 5,000 and you have F as so P, this is P and this is F as 1,000, and this is your 5 years 1, 2, 3, 4 and 5. So, we know that we can get this P multiplied by A by P I 5, A by P and then 10 5 minus F of A by F and then you have I 5. So, that also you can get, or else you have this as P minus F of A by P then 10 and 5, and then you have plus F into I. So, this also factor can be used to get that. Now, we know that this P. So, if you take the 10% of table, you can go and see the 10% table, and for the 10% table basically we need A by P 10 5. So, it is coming as 0.2638. So, this value is coming as 0.2638. P minus F is basically 4,000. So, 4,000 multiplied by 0.2638 plus F is given as 1,000 into the interest rate is 0.1. So, this is how you are getting the capital recovery with return, and this amount is coming out to be so this will be something close to 1,000 and then it will be 100. So, it will be 1155. So, basically we are getting this 1155 rupees that is known as the capital recovery with return, and this will be mostly used for such cases. In many cases you have you need to represent those cases where you have the capital cost, and then in the end you also have the return in terms of selling of the items and the salvage value of the plant. Now, we can also deal with another situation for such problems of the capital recovery with return. Suppose you have one company which has been given the two mutually exclusive alternatives, and suppose the for the first initial cost which is there, the investment cost is for alternative A is given as minus 10,000, and then its salvage value. So, salvage value is given as suppose 1,500. Similarly, you have the another alternative B, and it has the initial investment is minus 12,000 and the salvage value is given as say 3,500. Now the time is suppose 5 years. So, if n is say 5 years and you have to compare the capital recovery with return for the two cases. So, for the two cases an interest rate is suppose the interest rate is given as 10%. So, or we may have interest rate is taken as say suppose 15%. So, you take I as 15%. Now, you can basically calculate the values of the capital recovery. Now, capital recovery if you take at 15% for A. So, it will be 10,000 minus 1,500. So, it will be so this is P and this is your F. So, 10,000 minus 1,500 it will be 8,500 and then A by P I n. So, A by P I is 15 and n is say 5 plus salvage value is 1,500 into interest rate is 0.15. So, similarly A by P 15,5 if you have to find A by P and 15 and 5 will be 0.2983. So, it will be 0.2983. So, that will be the one and then if you take so suppose capital recovery of B option, then in that case you can calculate as 12,000 minus 3,500. So, again it is coming as 8,500 and what you see is again you have the factor A by P 15 and 5. So, it will be 0.2983 and then plus F I. So, in this case the salvage value is 3,500 and you have I as 0.15. So, what you see that in such cases when your P minus F is same, in that case it is obviously you can come to this conclusion that since these two quantities being same, we see that this amount is larger because this is 3,500 and this is 1,500. So, you can come to the conclusion that CR15B is more than CR15A. So, basically it will be the one. However, now if you are further told that what should be how much your salvage value of this amount should be less, so that their capital recovery cost is same. So, in that case you can say that by what it should be increased or decreased so that they become equal. So, you know that this is 3,500 and difference is, so if it is 1,500, in that case both will have the same capital recovery. So, basically by looking at such situations you can come to the different conclusions. Now, so what we discussed in this lecture, that we have two types of finding these equivalence formulas. We have discussed two types. One is your capitalized equivalent, where we normally use this concept of finding the present amount and that present amount will be giving you some return in future in perpetuity. So, in that case that will be used for many a times the societies may think of setting certain funds which will be required for the maintenance of the club, suppose. So, in those cases when you know that what will be the expenses and how, if you are even taking the increment in the expenses after maybe certain years, in those cases that concept of the capitalized equivalent amount will be utilized. Similarly, whenever you have to discuss about the capital recovery, you have any plant where you have the initial investment putting in, and then ultimately you have the time period which is defined for which the investment is going to run. So, in those cases you will have also the salvage value earning. So, that will be at the end of its time period. So, in those cases you are going to deal with such situations, and basically how much return is coming, that also will tell you that in what way the capital recovery cost will vary. So, different types of problems basically you can deal with, you can solve the problems that will be given in the assignments, and you will be having the more and more understanding about this type of problems, which will help you understanding these financial transactions of certain these type of organizations. So, that is about these two concepts of capitalized equivalent and capital recovery with return. Thank you.